Hello, my name is Adam Chernick. Thank you so much for coming to my talk, Digital Twins and Immersive Mediums. I'm so excited to be here with you this year at BIM Coordinators Summit 2023. Let's jump in. I'm going to dive into a little bit about our team, a little bit about myself. I'm also going to dive into some of the spatial focuses of AWS quickly, and then I'm going to jump into the meat of the conversation, which is going to be building information model integrations into different technologies and sort of the current state of interoperability of building information model data and how to leverage that data in these new mediums into digital twins and other immersive mediums. And so I'm really excited to jump in here quickly about myself. I am a spatial computing solutions architect at AWS, and so I'll tell you a little bit about our team and what that means. But really at heart, I am just an architecture design technologist nerd. I've studied architecture in undergrad and graduate school. I got the opportunity to work at some very large firms on some incredible projects, and eventually got to lead a research and development, an applied research team where we built custom tools. And I'll talk a little bit more about that. But started my building information model journey in about 2010 in Colorado, building huge mountain homes in the Rocky Mountains. So yeah, this is me. I'm an AR VR developer now. I'll talk a little bit about that transition, architectural designer, 3D modeler, UI UX. I love to make applications easy to use so that we can gain adoption. I like web development and now solutions architecture, which is, how do we make these applications secure, reliable, scalable, durable for huge numbers of people. And so really, I'm just a nerd who likes to build things, and I'm really excited to be here and nerd out with all of you. So I was a building information modeling specialist, BIM manager. I got to work on a lot of incredible projects from a building information modeling architecture perspective before my transition to software development, AR, VR, and spatial computing. And so this was the last project that I led as a building information modeling specialist, was World Trade Center 3 here in Manhattan, in Lower Manhattan. I got to work on a substantial portion of this project for about a little over a year and a half, and it was an amazing project to work on with HOK. So a bit about our team at AWS. This is what we do. We're a prototyping team. I work on a team called PACE, Prototyping and Cloud Engineering. And so that's exactly what we do. We work with customers who typically are already on AWS and building things on top of our infrastructure. And we build a prototype. So if they have a pain point, we work backwards with them. And if they have a pain point that we find, we can help build a quick prototype to alleviate and address that pain point, and then unlock a new potential feature or functionality or product for one of these customers. And so that's usually a 6 to 8 week engagement. And so that's what our team does. Our team is not specifically focused on AEC and real estate and digital twins, but we do work on those quite a bit here and there. And so since I am sort of the AEC expert on the team, I am working on those projects more frequently. A few past prototypes, fun things that our teams worked on: XR streaming. We work on some computer vision, object classification, photogrammetry, so 3D scanning pipelines for NERF and LiDAR and photogrammetry, so reality capture mechanisms, and then NVIDIA's Omniverse and how to sort of deploy that on our infrastructure. And I want to take a moment there to talk a little bit about AWS itself and what AWS is. I'm sure that a lot of you already know, but if you don't know, AWS was born because Amazon built Amazon.com, and it was one of the most scalable web applications and web infrastructure out there, right? Amazon.com needed to be accessible and secure to millions of people on Earth. And so we realized that the infrastructure that they built could be useful for anybody trying to build any type of application or workload on the cloud. And so that's what AWS is it gives anyone, any company, any developer the ability to access and build on top of the same infrastructure that is used for Amazon.com. So a little bit of overview of spatial at AWS, right? There's lots of spatial problems now. Three-dimensional data is inherently important to every industry at this point. More stakeholders are requesting 3D model data. Stakeholders are more distributed. The physical and the digital worlds are converging, right? Speaking to digital twins. Immersive hardware is more scalable. The tools, the physical products are getting better and better. And now game tech has entered the room, right? Game tech, these tools that used to be leveraged to build video games are now being leveraged in enterprise to create applications that are solving industry problems and addressing needs and addressing pain points and allowing companies to answer questions faster. And there are dollar values to that. So some of the industry challenges, there's lots of challenges to these problems. 3D model accessibility, 3D talent gap, technical complexity, right? Understanding how to develop software is one thing, but how to incorporate these 3D assets is an entirely another scope of knowledge that companies need to have. Constrained devices, spatial data, network bandwidth. All of these are really important challenges to think about. There's lots of benefits across the AECRE lifecycle when you're thinking about digital twins and immersive mediums. We're able to accelerate the development lifecycle. A lot of these tools are able to allow stakeholders to answer questions faster, make decisions in a more informed way, and gain all of the comprehensive necessary information that they need to make a decision. Reducing training costs, enhancing buyer experience, and improving building operations and maintenance, really important pieces here. Some of the industry use cases that AWS cares about and is working towards, of course, there's more than this. Collaborative 3D review, virtual facilities, immersive training, enterprise microverses, immersive commerce, and augmented operations. These are all sorts of some of the key building blocks that we are working on. Some of the industry customers and partners, there's a lot from AECRE and some of the technology leaders in the space as well. And so now let's jump into the meat of the presentation here, BIM, right? I'm a BIM nerd. I imagine that a lot of you are BIM nerds. I'm excited to talk about the current state of building information model data and interoperability of BIM data between new tools. And this is an incredibly exciting moment that we're in because there's a fundamental shift happening. It has never been so easy to move three-dimensional model data and the embedded BIM metadata between different tools. And that poses huge value adds in many, many different points within the development lifecycle. One is in game engines, right? We talked about these game tools that are so exciting. How do we bring this building information model data into game engines, into Unity Engine and Unreal Engine? You're able to now access all of this building information model data in these real-time engines, which allows so many different use cases because these game engines, these real-time engines, are able to develop and deploy applications to many different mediums. In a real-time engine, you're not just building a mobile application or a web application. You could also be building a virtual reality application or an augmented reality application or an application for a VR cave or some random hologram device or any medium. This is a cross-platform development ecosystem. So now you're exposing this BIM data to develop applications for anything. And that's really exciting. So Unreal Engine, Unity has Unity Reflect, which makes that really easy. Unreal Engine has the Datasmith CAD importer plugin, as well as the Datasmith Revit plugin exporter and an IFC importer. So there's multiple ways that you can get this embedded metadata into these applications and then start building business logic around that. Another one, so those are both real-time engines, so you can build for many platforms. And then there's also web, which is really, really important, right? And so Autodesk Platform Services makes it really easy for people to build web applications that are pulling 3D model data and its embedded metadata into web applications again, and then you can build business logic around that. So all that's to say is that now we can grab that BIM data and those 3D models into any type of application and expand and build and tie into all of that existing work that we've done, that we've put into building those 3D models. And that's really exciting. So some fun topics that I want to cover here in the end of the presentation. The last bit here is we need things to become easier still, right? A lot of, if you wanted to tie in this interoperability and build a custom tool, there is a certain level of software development experience that you need. But there are a lot of out-of-the-box tools that are making it very, very easy to leverage this information without needing those skills. And so I'll talk a little bit about some of these abstractions, right? This is a really important piece, is again abstracting a lot of that complexity away. Another exciting thing to talk about is a tie-in between LLMs, large language models, and BIM, right? AI and ML, and sort of how it's related to building information modeling. It's so exciting that, at least from my perspective, when I used to click on an air handler, or a duct or a piece of machinery in a BIM model, and I don't know anything about this piece of machinery. It has its product number and product name and some additional information. Maybe it's, volume or dimensions. I don't know what that is. And it would be incredibly helpful for me, even through the design and development experience, let alone the facilities management and operations experience, if I knew additional information about what this was, potentially how to maintain it, potentially how often it needs maintenance. And so we'll talk a little bit more about this, but LLMs tying to building information model to actually create actionable insights is really important. And then another one that I want to talk about is a pattern or maybe a potential pattern that could arise, which is, do these building information models already have enough metadata that we need, or do we need to pre-process these building information models more to create additional data points, additional pieces of custom metadata to enable these use cases downstream? And I think that it's becoming evident that there are some pre-processing steps that could enable some really interesting use cases downstream. So let's dive into some immersive mediums. So huge shout out to Shop Architects for providing some of these videos. That is my alma mater, and I got to work on some of these applications. So this is a Unity application where we're tying building information model data directly into an augmented reality application, where we're clicking on the panels, the window panels of this tower, and these panels have that embedded metadata to know their status. They know whether that panel has been installed, or whether that panel still needs to be installed, or if there's a crack in that panel. All of that embedded metadata can now be viewed and interacted with in a new intuitive medium. Construction administration, right? Creating new, I believe that, and we're already seeing new interaction modes and new query mechanisms because of this embedded metadata. Now we can again, the pre-processing step, we can tell a wall which drawings that wall is associated to. So when we click that wall, we actually are able to pull up all the associated drawings instead of jumping between A304 and and all of the different, these construction document sets can be thousands of pages long, and just navigating through these sets can be incredibly difficult and time consuming. If we can decrease the amount of time that it takes to obtain necessary information about specific components or elements in these projects, there can be huge implications. And now tying building information model data to these new mediums can do that. And that's really, really exciting. Simulation and BIM data, right? If we know occupancy counts, right? If we embed that information into these building information models, we can create and automate simulations of these spaces just by relying on that embedded metadata. That's, again, what tying this interoperability between these software can do. LLMs, we talked about this, right? How do we take something that wasn't previously actionable and was honestly more confusing than it was helpful, and now make it instantly actionable? And that's creating easy to comprehend analysis of different pieces of information. Using large language models, we can send a query of a specific part or element that might look like gibberish to us, and now we can understand exactly what that is, why it exists, what it does. We can also understand how to maintain it, what are best practices, and what are sort of things to look out for when operating this type of machinery. All of this can be done by leveraging a combination of LLMs and this building information model data. And I think we're going to see a lot more of that in the future. Here's a quick example, a few quick examples of projects that we've gotten the opportunity to work on. We built a digital twin for a new prototyping laboratory that we have in Manhattan called the Builder Studio. We built this digital twin that's leveraging a BIM model, 3D scan from a Matterport camera, which we'll talk a little bit more about, and then some IoT data. So we're pulling in live humidity and temperature data from around the environment. So this is what it looks like. And then I'll talk a little bit more about another medium here, which is another service, which is AWS IoT Twin Maker. So this is AWS's digital twin platform where you're able to import your three-dimensional model, and then you're able to leverage AWS's existing IoT core infrastructure to start to overlay your IoT data on top of these 3D immersive environments. You're able to set up flags and indicators. If a specific metric is below this threshold, give someone a warning. And so this infrastructure right now is currently under development, and they're making a lot of progress with TwinMaker. So keep an eye out on the progress of this. And here's just an example of something you can build with TwinMaker. So this is a building management solution leveraging AWS IoT TwinMaker. So you can click into a specific area, you can click into a specific facility, and then you can start to pull information and IoT data out of that specific, location. And so to take this one step further, right, we are embedding these three-dimensional building information models into AWS IoT TwinMaker. We're creating knowledge graphs on the top right. You're actually creating graphs that can represent relationships between different elements within this model. And as you're navigating through this model, you are pulling that building information model data into the bottom right there. And so this is a demo of AWS IoT TwinMaker. This isn't all embedded into the service yet, but this is a great glimpse into what's going to be possible here shortly, what's already possible with this technology. And then just speaking to the fact that we have a partnership between Matterport and TwinMaker now developed, which makes it very, very easy to pull Matterport scans into AWS IoT TwinMaker and build digital twins very quickly. And then to speak a little bit further about Autodesk Platform Services and how we can do all of this in the web, right? And so we can pull these building information models into a web viewer. We can access all of that building information model data, and then we can overlay all of this different IoT metadata and additional IoT data within this web experience. And then, immersive mediums. So Autodesk acquired a company called The Wild, a really amazing virtual reality tool to allow architects, engineers, general contractors, anyone within the AECRE ecosystem, the ability to jump in a multi-user experience and dive into these projects and do QA, QC, quality assurance and quality control, and facilitate entire consultant meetings and customer meetings within within this immersive medium, and pull building information model data from their models in order to facilitate. And then this last one, which is fun to talk about here, is SimSpace Weaver. We have this new service which is able to create simulations at massive scales. And so you can bring your building information models into real-time engines like Unity and Unreal Engine, and then create a simulation. This is a pedestrian simulation. A lot of what SimSpace Weaver is doing is for simulations that typically would be much too large to develop on your local machine. Now you can develop the logic of the simulation and then split that simulation up into the cloud. It goes and actually runs the simulation and does the calculations, and then comes back to you with the result, which is, again, very exciting that we can build simulations at much larger scales that are also leveraging your building information models. So that is all that I have today. Thank you so much for joining this presentation. It was a lot of fun. I am excited to answer all of your questions about building information model interoperability and any of these different topics. Please connect with me on LinkedIn. I'm pretty active on there, and I am looking forward to chatting further. Thanks so much.